Welcome to the Databricks Skill Builder series. We're glad you're here.
So today we're going to be doing an introduction to Databricks SQL, I'll just go ahead and jump right in. I've got a few topics that I want to talk about. First, we'll cover a few training opportunities in the Data and AI Summit that is coming up in June. And then when we go into the Databricks SQL talk itself, I'm going to just do an overview of the Lakehouse. We'll talk about the platform interface. So this is the Databricks interface for SQL. Go through the SQL editor, queries, dashboards, and performance. So first, I just want to touch base on, we do offer quite a bit of free training. There's some upcoming trainings on fundamentals of the Lakehouse, as well as some onboarding sessions that are upcoming. There is platform administrator training later this March. And I want to point out, you can always go and look at additional training opportunities. This is databricks.com/training. I'm just going to scroll down on this page, and at the bottom, you can go through and see instructor-led training as well as other events. Another thing I want to talk about in terms of training and onboarding, which I think is really excellent. In fact, some of the examples that I'm doing today come from this, but this is our dbdemos.ai site. Excuse me. This is a great way to do some experimentation with the Databricks platform. And in fact, I'm just going to scroll down here. We've got several that are labeled, we're going to be doing DBSQL, so you can see this purple call out in terms of tagging. There are several demos that you can just download. They're very easy to install and leverage that specialize in BI, data warehousing, and Databricks SQL. We also have the Data and AI Summit coming up in June. Just wanted to talk about this very briefly. There will be keynotes, breakouts, networking opportunities, and a lot of training opportunities. There is a virtual session. Those are all free, but you can sign up via this link to the Data and AI Summit. For on-site content, please check out this link or talk with your account team about potential costs or discounts. Moving into Intro to Databricks SQL. This is going to be about a 1-hour session. Again, I'm Peter Davis, Senior Solution Architect. I work principally with media and entertainment teams at the moment. I did also want to call out in here, there is a deep dive webinar that is also free, which goes quite a bit more into the platform. So I would take an opportunity for that. There's a registration page and you can sign up for it. Okay. But again, it's free, it goes into quite a bit more depth than I will today. So before we get into DBSQL itself, I want to talk about why we built the Lakehouse, and it ties directly into modern data warehousing as I've experienced it. And in the past, and I'm just going to set some context for why Databricks built the Lakehouse, proposed the Lakehouse in the first place. And that's because over the past 40 or so years, there's been a rise of data warehousing and then also descriptive and predictive modeling. So on the left, you've got a typical data warehouse. This came up in the 90s, early 2000s, where what we do is we take our data that the organization has and we try to get value from it by putting it into very structured tables. We've got dimensions and measures. So a dimension would be something like date or geography, and measures would be things like counts. And we do a lot of preparation for it. We do extract, transform, load, do a lot of preparation, put it into these tables where we can do fine-grained access control. So we've got access control around rows and columns. And that allows our analysts to, first of all, securely access our data, but also because we're pre-aggregating it and we're preparing it so much, it's very, very fast. So it's been great for descriptive reporting, where we've been. Since the early 2000s, the rise of the data lake has occurred to handle the massive volume of data that's coming from Internet of Things. So for instance, cell phones, any Internet of Thing device, smart TVs, et cetera. But it's also unstructured data. We're not doing that whole, let's orchestrate a really tightly defined table. We're beginning as logs, text, blob files like images, video, audio. And because of that, we're handling it on a file-based level in terms of security, rather than a table-based level. But the real advantage is it allows our data scientists and machine learning engineers to produce predictive models about what we want our business to be. We can meet our business where it is. The challenge is that over this, we've got one structure for data warehousing and we've got one structure for data lakes. And this means that we're propagating data into both platforms, which means that they're disjoint. We have to do that labor to get the data into both places. We typically start to see drift from the data, because there's a lag between copying and between the systems. We also have two different security models. This is less of a concern for analysts or folks who are strictly in DBSQL, but I want to highlight it as one of the challenges that all of our teams and our organizations have faced over the past 20 years is that we have to spend a lot of money maintaining table-based security as well as file-based security. Finally, and most importantly, we have incomplete support for use cases. So on the one side, we're doing analytics and descriptive modeling. On the other side, we're doing predictive modeling. And one of the challenges I've seen in my past is where our analyst may come up with a metric that's really important, and our data scientists take advantage of it, so they recalculate that. But then that metric changes, say a revenue operation or some other metric. The definition changes, but not everybody gets the message immediately, and that means that we could be doing reports that are out of sync, and especially reports up to leadership or to external parties, and that's always a challenge for the organization. So the Databricks Lakehouse platform addresses this by, first of all, we land all of our data into one data lake. So it's all of our raw data, same sort of blob data that I talked about before. And instead of silos, we have one platform to store and manage all of our structured, semi-structured, and unstructured data. We have one security and governance model. Remember, I talked about on one side, we're doing file-based security. On the other, we're doing table-based security. Here, we're all doing one model around file-based security. We also reduce duplicative costs in storage. We're no longer having to push data into both platforms. Benefit is all our data is governed and secured in one single approach, and all of our folks can leverage the same data. We don't have to reproduce two data pipelines. We don't have to reproduce the data. All of our folks can use the data in that one environment. And Databricks in particular has pioneered a couple of open source technologies, but most significant in this context is Delta Lake, the Delta tables, which allow us to bring the security and reliability and performance of the data warehouse to the data lake itself, providing ACID compliant transactions, things like audit history, time travel. So it's the best of data warehousing on the data lake. And Databricks in particular provides Unity Catalog, which enables discovery on our data. We get that fine-grained access control that we talked about over in the data warehouse. And we also get to do audit tables and lineage on our data. We'll talk about that a little bit later in the demo. So it's not just, it's not just that we get one platform to do all of this. One of the great things about the lake house is it's also very, very fast. There's an industry standard benchmark called TPCDS. This is a decision science benchmark. It consists of 100 queries or so that really test how fast a data warehouse is. And the good news is Databricks, in terms of price and performance, has an overwhelming advantage for data warehousing today. And on the right, what I want to highlight is the concurrency. Databricks started about 2 years ago with the data warehousing initiative, and our concurrency, our speed wasn't great across handling workloads in parallel. You can see that just within 6 months, we had incredible performance, and today we outperform the competition in concurrent processing. Moving into the interface itself, I'm going to touch on a few interface points as well as a couple of features that are coming up, and then I'll go into the demo itself. So first, the Databricks query editor. Let me just move one window here out of my way. There we go. So Databricks offers a full-featured SQL editor that allows analysts to write queries in ANSI SQL or Spark SQL. So you can see the query editing window. On the left, we have a schema viewing pane, and you can also see that something that's I find delightful about this editor is that we can do charting visualizations right in the editor itself. So it really helps with immediate data exploration within the platform ecosystem itself. any of those visualizations, so those charts that we just saw in the query editor, can also be attached to a dashboard. This is great, again, for exploration within the platform itself. But we also encourage you to use your BI tool of choice. So we have native connectors that make it easy to leverage your data from tools like Power BI or Tableau. One of the interesting things about leveraging external tools like Power BI or Tableau is that you often have to wait for data to propagate over. And Databricks introduced a tool called Cloud Fetch, which really improves, it parallelizes those queries. So if you're pulling a very large table, what we can do is spread that out across multiple pulls and get up to 10 times the performance on that pull. So it makes using things like a Tableau or Power BI much more satisfying as an experience, as well as reducing the latency to being able to see the data in those tools. Quick highlight for, we'll talk about serverless in a little bit, but as part of this DBSQL intro, when we are analyzing data, there's two components to it. We have our data that's sitting out on disk, but then we're going to do the actual analysis of our data. And to do the analysis of our data, we're doing it in a compute space. So we're loading it into memory and running it across processors to actually do our transforms or our analytics. Typically, that has been handled by spinning up clusters where you have to wait for that cluster spin up time, and you're paying for that cluster spin up time. Databricks has introduced serverless compute, which just to sort of summarize it, what we have is we have a pool of resources that can then immediately be leveraged. You save that spin up time and you save overall costs. On average, with our customers, we've seen it lower overall infrastructure costs by an average of 40%. And we're doing this because rather than having to configure the clusters yourself, we're helping to determine the best types and configuration for the price performance that you're looking for. Three features that are coming. One is query federation. So this enables us to query remote data sources. So you've got the data that's in your Delta tables in Delta Lake within Databricks. You may have data that you need to query in other sources that are remote. So this will allow you to do that directly in your code. And it helps to break down barriers within an organization. Second thing I want to point out as a feature that's coming soon is materialized views. So if we're not familiar with views, if you have data in a table, you have data in another table, you can join that. You can create another table, or you can define a view. The view is code that executes in real time when you call it, and I'll show an example of that later. But here we have a sales report. It's joining sales and store info to create a report. But when you do that in a view, you're doing that in real time. So you're saying, hey, join all this data, give it to me right now. And that can be expensive if it's on a very large set of data in the underlying tables, because you're doing that, stitching together the data immediately, doing whatever filtering the view calls for. So there may be some latency there. Materialized views allow you to do that same view definition, but it will pre-compute those results for you. So as updates happen to these underlying tables, it'll incrementally update the materialized view. So the benefit is that you have this dynamic view. You've got this thing that's really easy to define, but because it's materialized, you get the benefit of performance. Again, that's coming soon in different areas within the product. Finally, user-defined functions. So often in SQL, you're doing some calculations within SQL itself in the columns that you're pulling up in your query. User-defined functions allows you to do more complex transformations on that data, and also call other functions like, say, a predictive model for machine learning. So it allows you to integrate things like machine learning models directly into your SQL code. Okay, with that, I will go ahead and jump into the demo. I do see two things in the chat. Let me just, okay, cool. Just wanted to make sure that we didn't have any questions. Get rid of the training examples, and we're just going to talk about the Databricks interface. So I want to orient you to the interface itself. There's a left-hand navigation, which we'll go into in detail. There's a top navigation, and then there's a center work area. The center work area is where most of the interaction comes. So you'll select something on the menu item, and then you'll interoperate in the center area. We've got a query editor, sample dashboards on this. This is the home page. One of the things I like is the recents area, where I can see the queries I've been working on, as well as any favorites I may have selected. In the top nav, there's a pretty sophisticated search facility where you can look up things like prior notebooks that you've worked in or dashboards. You can also see which work environment, which workspace you're in. The little present icon shows you upcoming things or new things within the interface. And then I can look at either go to help or look at my account settings. On the left-hand nav, there are three personas that we have in the platform. There's data science and engineering, we have machine learning, and we have SQL itself. We're going to stay mostly in the SQL interface today. So as an analyst, this is the interface I would be using. The new button is just a series of quick links to create new items in any of these menus below. For instance, a query, we could generate it here. I'm going to stick to the other interface items. I'm going to go into the SQL editor. One more window over here. And I'm just going to check. There we go. Okay, in this query editor, so this is a fairly standard for the experience I've had with other SQL editors out there. Right? We've got an integrated development environment. We do have some IntelliSense. There's a tabs up here, which allows us to, I've got 3 queries already up in these tabs. I can create a new query by hitting the plus sign. And this would be the area where I do my SQL statements. You can see that there's type ahead sort of IntelliSense. So I can say select turbine, whatever it may be, the turbine table. In the top part of the editor, we have a couple of options here where I can run all of my statements at once or just a single one. I also leave the default of limit 1,000. So if I do a query against a large table, it'll limit it to the top 1,000 result, but that can be disabled. In the query, in the Databricks ecosystem, we are using Unity Catalog, which I mentioned briefly in the slides. But this means that there's a 3-level namespace to the name. So currently I'm in this window, I'm in the Hive Metastore catalog. I'm in the default schema, and I've got a variety of tables available to me. Finally, over on the right-hand side, I can do things with my query like clone, edit info, format the query. I can also choose the compute that I'm going to leverage as part of this. Currently, I'm just going to leave it as our shared endpoint, which is a serverless compute. I can save the query, and I can also schedule it to run at a variety of times. With the interface out of the way, I'm going to close this and come into the left-hand side later. I'm going to come over to a couple of queries that I already have. So I'll just do a typical show tables, which you would do in most databases, and it will show me the tables that I have in this database. You can see, again, I'm in the main database with Peter Turbine Demo, which is some demo tables that I put together for today. And I can execute a full query just by highlighting it and clicking run. And I can also execute a partial query, right? Just by selecting part of it, also hitting run. Like any other SQL editor, you can see here that this is, by the way, this is all simulated data. It's turbine data from that DB demos AI. So there's no confidentiality with anything you're seeing in this demo. I can also filter by specific turbine IDs. I already have one selected here, so I'll go ahead and hit that. And when we see the results, we can see that they're all filtered by that ID. There are 2 ways to do more dynamic filtering. So there's the typical, well, there's the where clause, which is what I just did, right? But I can also do a token. So I've got this right here. I've got this table of sensor bronze. Bronze refers to raw data coming in. There's I don't really have a diagram for it, but there's a concept of we land data as raw data in bronze. We curate it a little bit, put it into silver, and then we prepare it for reporting in terms of aggregations and all that, and that we would call that gold. So this is the equivalent of raw data that I've copied into my database. And I can just say the turbine ID equals, and I can put a parameter here of the turbine ID again. So this becomes a token that gets passed into the model. And something I just want to show here is I'm going to just take this away. If you look down here, there's going to be a parameter that appears. So I'll go ahead and hit paste again. And you can see that as I've added this tokenized parameter, this filter has appeared within the query window itself. It happens to have the turbine that I've already selected. You can see here that we've got all kinds of turbine IDs. I'll go ahead and run this query. And we've filtered to the turbine ID that I embedded into the filter here. Okay. To grab a query here, this current status. I want to show two other elements of this. Okay, so I'll do select from turbine current status. I just executed by hitting shift and return. It's the equivalent of highlighting the query and hitting run, or hitting run all. And on that, we can see that I've got all the turbines here. What I want to do is add a filter. This is just another way of filtering the data that is very low code. So I'm going to choose the location parameter, and I'll make it multi-select. And I'll hit save. And this will allow me to select, this is again the same query, but because I've added that filter down here on the dashboard, I can select, say, Beaumont. You can see we've immediately filtered our results. And then maybe I'll add in Collinwood. Okay, and we can I'll scroll right so you can see that we've filtered our results to Beaumont and Collinwood. I can also add visualizations. Show this in the slide deck, but right here I can toss in. I can click on plus and hit visualization. And let's do a line chart. And for the X column, we'll do, say, energy, and oops, sorry, I'll do timestamp. And then for the Y column, I'll do energy. But I'm going to go ahead and group by that location that I just chose. And so if you remember, I filtered by two locations, Beaumont and Collingwood, or whatever they were. Oh, yeah, they're there, Beaumont and Collingwood. So we've automatically, by grouping, created a chart that has those two lines on them. And if I wanted to add another parameter, say Brighton Beach, I can. And so it's incredibly easy to do data exploration, look at visualizations right in the interface, get immediate feedback, and move on as an analyst. Yeah, as I mentioned before, I could also schedule this and save it. So if I wanted to save it, certainly can. I'll just say Peter Best, so I can remember to delete it later. I can schedule it to refresh. So this will actually have the query operate in the compute layer and refresh the results on whatever schedule I ask it to. And then I could share the query within the Databricks ecosystem. We'll talk about other ways of sharing in a little bit. Okay, I'm going to come down to the queries tab. This workspace tab, I'll touch on it just very briefly. It's just a way to go in and take a look at your codes. You can see these are the folders I've created. Here's the code I've created. So it's just another way to browse through the work that you've done. Queries tab itself. So this will show names of queries. This is any query you have permission to access. So names of queries, who it was created by, when it was created, when it was last run, and what the refresh schedule is. I can also filter down to my queries. So this will just highlight everything I've created within Databricks. You can see I've been doing quite a bit of tinkering around different things. You can also see that one of these is starred. When I click on here, it'll show anything that I've starred as my favorites. Last thing I want to call out is there's a pretty robust tagging system as well. These do interact. So if I click turbine right here, we're not going to get any entries because my favorites have not been tagged with turbine. But I'll go back to all queries. And then I'll click turbine as well. And what it will then show me is see these two lozenges. We've got power and turbine. So it shows me all the queries that have been tagged with turbine. I'm going to move down to dashboards. We touched on those in the slide deck. But what I really want to show is I'm going to go to favorites. So I've got two that I wanted to highlight. First of all, the interface is very similar to queries in that you've got name, created by, created at. You can also select down to just your dashboard, your favorites, and you can also reference them by tags. There's also a search facility to look up any dashboards. I'm going to go into this predictive maintenance dashboard and talk about this for just a minute. Again, this is a great way to do data exploration right in the system, and we'll go through how to connect to tools like Power BI and Tableau in just a little bit. Within the system, though, each of these panes, each of these squares or rectangles that you see within the dashboard itself is a query. It's a query that has had a visualization attached to it. You can tag the dashboard as we saw before. You can also share it. Similar to queries, you can schedule a refresh on the dashboard, the entire set of components on the dashboard, tell it which compute you want to use, and then have subscribers who will get an email every time the report refreshes. It's a great way to automate your refreshes of reporting. You can also refresh right now. You can see that in the lower left-hand corner of each of these widgets, this was updated about 14 hours ago. I'll just go ahead and hit refresh. And we can see that they've been defaulted to just now. This is pretty static data because it's a demo, so you're seeing it updated as just now, but point is that if we were constantly ingesting data, we would see potentially different numbers in each of these. So I can look at the underlying query that generated this. So I will go ahead and say view query here. I'll open it in a new tab. Okay, so here's the query itself, and then here's the visualization that was produced. So we're just going to go back to our dashboard platform and take a look. There's that 55535. Here it is again. This query happens to have two visualizations associated with it, right? The 505 megawatts and the 55,000. So you can also see, look, instant energy produced. So from this one query, we produced two visualizations and then attached them to this dashboard. And in a similar way, out of, again, dbdemos.ai, if you download those, install them, you can see quite a bit of mixing and matching in terms of how dashboarding's working when the data is right on the Databricks system. Finally, we can edit. So if I wanted to, I could X out any of these. I could also resize them, move things around. I'm not going to do that, but you can see that it's a fairly flexible facility to do all of that. And I'll go ahead and say that I'm done editing. There's a few other options that you can explore on your own, among them exporting, downloading as PDF, cloning the dashboard to then tinker on your own with whatever dashboard you've seen. I'm going to move on to alerts. So something, this is a series of queries that have had columns that have been identified for some parameter to be an alert. So I'll just go through the interface and then we'll mock create an alert so that you can see what I mean. So we've got a name created by what the current state of the alert is, when it was last updated, and when it was created. We can also do the same sort of filtering based on all alerts or just my alerts. We do have one alert that's out there, this alert for the turbines that has been triggered, and it's run on a fairly common schedule 32 minutes ago. So I'm going to create a new alert. We'll just call this Peter Tennant. And I'll go ahead and use this bronze single sensor filter query. So this is the one where I had the turbine ID in there in the SQL editor. And what I'll say is, say sensor A, what if that is over 7? Then I want to trigger the alert. And if that threshold value gets exceeded, I can say that I want to trigger it just once, And so it'll bug me once and then ignore it until the data is back to normal. So it goes below 7. Every time I detected it as above 7, or at most, 5 or 6 times until it gets back below 7. So we have a variety of ways to think about how much we want to bother ourselves with the alert. I can also use the default template, or I can do a custom email template around the alert itself. I can choose a refresh schedule. I want to call out that this is a different refresh schedule than the query refresh schedule that we looked at before. So alerts operate on their own. And then I can choose which compute the alert is going to operate in, remembering that we've got our data at rest on disk. Whenever we're operating on the data, we're leveraging compute in somehow or another. I'm going to move down to the Data Explorer. All right, in the Data Explorer itself, this is where we can search to find data in our tables and columns. And in this interface, we've got, I mentioned it before, but we've got three level namespace. So we've got what catalog we're working in, what database we're working in, and then the tables themselves. So I'm going to go to the main catalog. And in here, I'm going to go and just search on Peter so I can see this Peter turbine demo. Again, this is the schema or database that my data is created in. And here we can see those same tables. I'm going to open up a new, let me do this and let's open up in a new tab. So I'm coming back to this SQL editor and back to these basic queries. So I'm going to run show tables. So this is where we started, right, in the demo. In the SQL editor, I'm doing the show tables command. I'm going to go ahead and get rid of this dashboard. So in this Data Explorer, I'm basically seeing the same thing, right? But I get to view it from a schema perspective. You can see there's different icons for the tables. Here's icons for the views. In the table itself, I'll click on sensor bronze. I can see the columns, the data types. I can see any comments I might have made. So earlier, I went ahead and just added a comment of that critical sensor threshold being 7. I can edit the comment if I want and just put a little exclamation in and save that. You can also view sample data. Details on it. So I can see that this table is a managed table within the Unity catalog ecosystem. It is a Delta table. There's a variety of other information about it, including who created it, who updated it, when it was updated. There's a variety of permissions that are on there, and I can grant permissions to anybody on the table itself. And also look at the history of this table. And so this shows part of Delta table is that everything that happens to the table is kept as metadata on within the Delta Lake itself. So I can see that I did a create table as select. That's how I created the table I selected it from other data that I had. And then you can see that I also just did a change column. So you can see that the change itself was to change the comment to be this critical sensor threshold greater than 7 with the exclamation point. Another great feature is lineage. I'm going to go straight into the graph on this. So here's the bronze data that I was looking at. Here's a silver table. I'll click to expand and we'll move this out just a little. So what we can see is I have this bronze table. I moved it into being silver. I created a gold table from it, and I created a report from that. But the report pulls from 2 tables, this one of turbines by location, as well as turbine gold. Okay. It's a feature I personally love just because I am very nerdy about lineage and all that. I can also look at insights, but because I haven't done a ton of queries, there's only a few. So this is looking at frequent queries against the data. So it's a way to come in and analyze what's been happening on the tables that I've created. Yeah, just doing a quick time check. I want to move down to the compute layer. So we're going to move back to that same SQL persona. And compute happens within the SQL ecosystem within warehouses. So this is compute you can specify to run the SQL-based workloads, whether it's queries, as we talked about, those alerts, data sharing, dashboards, or connecting other BI tools, right? And so I'm just going to simulate creating a warehouse. Just give it a name. You specify a t-shirt size for the cluster. We recommend starting out with medium, just to get a sense of how things are running. You can tune it from there. You can tell it to stop running if there's been whatever number of minutes of inactivity. You can also scale it up if you like. The serverless option, again, that's where you get almost instantaneous compute because we've got resources waiting for you to consume them. The Pro option has the same features as serverless, but serverless is where many features are going to be built. But Pro has a lot of the advanced features, and one of the things that I want to emphasize is when you do Pro, you actually have to specify the cluster configuration, and then you'll also be waiting for that spin-up time. And then Classic is a legacy set of clusters that has a reduced set of features. Two things I want to call out in advanced options are you can tag your clusters, and there are tool tips here, but the important thing about tagging is it helps you track usage within your cloud provider. So if you're using that Pro and say you're in Azure or AWS, it'll help you see which clusters used which resources because you've got that tagging back to the systems. You can enable it for Unity Catalog. The last thing I want to call out here is the channel. So in current, what you get is features that are currently generally available, meaning that they are fully productionalized, fully tested. Preview allows for things that are in public preview. So they're most of the way there, and we're trying them out on a larger scale. So there is, if you use preview features, they are subject to change, but it's also a great way to see what's coming down the road and to test it out once it's in public preview. I'll touch on query history. So something I'm going to move back to the SQL editor. So we've got both query history and SQL editor there. There's something I did not mention within the SQL editor itself that I wanted to, which is, let me go to name. And we'll go to Peter. Go find demos. This is another way to see your schema within the SQL editor itself. Within a query, you can also look at past executions. Just to highlight this briefly, this is this SQL editing pane where I can go back and look at prior queries that were that I executed within the same edit pane. And just the way I've worked in the past is I've had these very long SQL windows where I'm doing all kinds of experimentation. And there have been occasions where I've deleted something or wanted to go back to a prior run. This is a great way to do that. So it suits my working style perfectly. It may or may not suit yours. The other thing I wanted to call out is down below, when you are in the query editor, you can click on in the lower left and see statistics on how the query was run. So you can see how much time it took in scheduling, running, start time, end time, et cetera. You can also see a profile of the query. The reason I went back to this is because I'm about to show you the same thing in query history. I just wanted to point out to you that directly within the SQL editor on a query, you get this information right at your fingertips. So again, it's in the lower left of the window down here. I'm going to go back to this query history. So this is where we are in the menu. And this shows you all the queries you've run for the last, right now I'm filtered to May, the last 14 days against any SQL warehouse that I've used, whatever duration of the query it was, any status of the query, queued, running, finished, et cetera. So this is a great way to sort of review my work, take a look at it. I can also potentially look at others that I have permission to. Then it helps me to analyze my longest running queries and perhaps take a deeper look into them. So I'll go ahead and click on this query name. Here's that same window that I saw in the SQL editor, right? It shows me the query itself. I can take a deeper look at that just by clicking on expanding the query. I get an overview of it, who created it, what DBSQL version did it run on? What was the SQL warehouse that it ran on? What's the source of it? This happens to be the alert that I've already created, so I could go and edit the alert query if I wanted. And then some summary statistics about the query itself. So we've got this wall clock, meaning how long did it take me as a human to observe the query to finish? How long within that overall execution time were we in scheduling, waiting for compute, waiting in queue, and then various attributes about the running time. There is also a, actually, I'll go into the query profile on this. Switch my window just a little bit. In here, we've got two views, graph view and tree view, where we can take a look at the query as it executed through its process. Tree view is nice because it gives me a real sort of visceral examination of the different steps within the query processing itself and the execution time of those. I get some summary statistics over here. For instance, did I actually operate off cache, meaning the query was already in memory? Did I have to go to files? So I really encourage you to examine this on your own. We also have some information about query profiling on our site. The last thing I want to touch on here is you can enable verbose mode, which really goes into deep detail about all the steps that happened within your query execution. So with that, I'll go ahead and close this window and close that one. The last thing, two things I want to touch on today. We do have a marketplace. This is in preview. This is where you can examine data that's available from data providers, other data providers who are providing it for you. It's also a way that you can potentially put data out there for others to use. The Partner Connect ecosystem. This is not an exhaustive list of all the partners we have, but it does make it very easy for you to see different partners that are available, filter on them. And what it really makes it easy is for you to connect those partner ecosystems and leverage that tooling. So for instance, if I go into Power BI here, what I can say is, well, I want to use this compute for this. It allows me to download a connection file that's already pre-built for me. So it makes it very a lot easier to connect. You don't have to go hunting different sources for code in order to connect. That is pretty much covers what I wanted to cover today. Do we have any questions out there from any folks on the call? I don't see any in Q&A. So Kwame, anything else that we would like to cover today? Hearing none, I will say thank you all for attending and happy computing. Cheers.